Good morning students. Welcome to 12th standard physics class. Today's topic is on communication system, unit 10. Communication system introduction. Communication exists since the dawn of life in this world. Growth in science and technology remove the locational disadvantages effectively. Information can be exchanged from one person to another anywhere on this earth. Right from the developments made in communication by great scientists like J.C. Bose, G. Marconi, and Alexander Graham Bell, communication has witnessed leaps and bounds. The communication industry is one of the largest in size and is the oldest since communication through telegraph, telephone, and radio started centuries back. Every sector in the world is experiencing a significant profit with the advent of global positioning system, அதாவது GPS. உலகளாவிய நிலையை அறியறதுக்காக satellite, mobile and optical communications. This unit provides a glimpse of the basic concept of electronic communication and its applications. Modulation. For a long distance transmission, the low frequency baseband signal is superimposed onto a high frequency radio signal by a process called modulation. In the modulation process, a very high frequency signal called carrier signal is used to carry the baseband signal. Three characteristics in the carrier signal can be modified by the baseband signal during the process of modulation: amplitude, frequency, and phase of the carrier signal. There are three types of modulation based on which parameter is modified. They are amplitude modulation, frequency modulation, and phase modulation. Amplitude modulation. If the amplitude of carrier signal is modified in proportion to the instantaneous amplitude of the baseband signal, then it is called amplitude modulation. Here, the frequency and the phase of the carrier signal remain constant. Amplitude modulation is used in radio and TV broadcasting. The signal is the baseband signal that carries information. We can see that amplitude of the carrier is modified in proportion to the amplitude of the baseband signal. Okay, advantages of amplitude modulation: easy transmission and reception, lesser bandwidth requirements, low cost. Okay, what are the limitations of AM? Noise level is high, low efficiency, small operating range. Next, frequency modulation. The frequency of the carrier signal is modified in proportion to the instantaneous amplitude of the baseband signal in frequency modulation. Here the amplitude and the phase of the carrier signal remain constant. Increase in the amplitude of the baseband signal increases the frequency of the carrier signal. This leads to compression and rarefactions in the frequency spectrum of the modulated wave. Louder signal leads to compression and relatively weaker signals to rarefactions. When the amplitude of the baseband signal is 0, the frequency of the modulated signal is the same as the carrier signal. When the frequency of the baseband signal is 0, there is no change in the frequency of the carrier wave. It is at its normal frequency and is called as center frequency or resting frequency. Practically, this is the allotted frequency of the FM transmitter. Okay, advantages: large decreases in noise. This leads to the increase in signal noise ratio. The operating range is quite large. Limitations of FM. FM requires a much wider channel. So frequency modulation transmitters and receivers are more complex and costly. In frequency modulation reception, less area is covered compared to amplitude modulation. Next, phase modulation. In phase modulation, the instantaneous amplitude of the baseband signal modify the phase of the carrier signal, keeping the amplitude and frequency constant. This modulation is used to generate frequency modulator signals. It is similar to frequency modulation except that the phase of the carrier is varied instead of varying frequency. The carrier phase change according to increase or decrease in the amplitude of the baseband signal. When the modulating signal goes positive, the amount of phase lead increase with the amplitude of the modulating signal. Due to this, the carrier signal is compressed or frequency is increased. The frequency shift in carrier wave frequency exists in phase modulation as well. The frequency shift depends on amplitude of the modulating signal and the frequency of the signal. What are the advantages? Frequency modulation signal produced from phase modulation signal is very stable. The center frequency called resting frequency is extremely stable. Okay students, today's topic is over. Today's homework. Students, I have given homework for you. Read the questions and answers well and write 2 or 3 times in your fair note. After writing, you send the answer to me. Okay students, thank you. God bless you all.